Hello. In this video, we will be discussing the chapter 6 inferences based on single sample. Let's go. The first thing, uh, let's know what we will be learning in this lesson. So, identifying and estimating the target parameter, and then we will be trying to understand the confidence interval for a population mean, and we'll be using the normal Z statistics and the confidence interval for a population mean, and we will be using the student's T statistic. And uh, we are trying to understand, to estimate a population parameter based on a large sample selected from a population and use the sampling distribution of a statistic to form a confidence interval and show how to select the proper sample size for estimating a population parameter. Okay, so the first thing first, identifying and estimating the target parameter. So you know what is target parameter, right? So our target parameter may be different. Say, for example, it is our theta. So theta is equal to, say, mean, okay, median, mode, all of these. So that is what we want to know. Let's go. So the target parameter, that is the unknown population parameter, meaning the mean or proportion, the mean, median, standard deviation. So that we are interested in estimating is called the target parameter. Say, for example, from this is our total entire population, and you know that it is quite impossible to collect the data for all the people living in an area. Uh, say our interest is to know the average annual income of an area of a city. So, say for example, in Albuquerque, so more than 600,000 people live, right? So if we want to um, uh, collect the data for all the 600,000 people. So it is quite impossible to collect data for all the 600,000 people. So what do? We will collect data for a sample population, right? And then our target is to understand the average annual income. And as we know, so we must collect the data randomly. Okay, we should not go to somewhere that most people go, because maybe certain type of people or certain group of people who has high or low income, annual income, they go there. So we should not be uh, going to a specific place in which the people with the similar type of income goes. Okay, then our target parameter example. So we want to calculate. We want to know. So the mean, the proportion, percentage, fraction, rate, or we want to know the variance, the variability spread, which is the standard deviation, or variance, and they are definitely the quantitative, not the qualitative. We want to know the number, right? So a point estimator of a population parameter is a rule or formula that tells us how to use the sample data to calculate a single number that can be used as an estimate of the target parameter, right? So the point estimator, now look at this, the number that we use from the sample to estimate the population parameter is known as the point estimate. So this serves as our best possible estimate of what the true population parameter may be, right? So an interval estimator. So an interval estimator, or the confidence interval, is a formula that tells us how to use the sample data to calculate an interval that estimates the target parameter. Look at uh, this image. So, for example, this is actually the level of confidence interval. If we calculate the mean from a sample, then our mean would be between this area, meaning we are 95%, this is actually 95% confidence level. So the probability that our mean will fall between these boundary, if we say it is 95%, we have 95% confidence, then our calculated parameter will fall within this boundary, and the probability is 95%. So 5% probability that, so it may be out of this boundary. So if it is 5% probability that it would be outside of this area, meaning here it will be why it is doing that, 0.05, okay, and 0.025 actually, 0.025, and here it will fall, the probability is 0.025, right? Okay, and then as we said, the confidence interval is a range of values, okay, that is derived from the sample data that is likely to contain the true population parameter with a specified level of confidence. So it provides an estimate of uncertainty around a sample statistic, such as the mean or proportion. So, for example, we want to calculate the average annual income of the people living in Albuquerque, and if we calculate the number, that is the average is 80,000, and our confidence interval is 70,000 to 100,000. So our calculated average is in between our interval. So according to the central limit theorem, the sampling distribution of the sample mean is approximately normal for large samples. Large means more than 30 observations. So let us calculate the interval estimator. So this is the most commonly used formula. So sample mean plus minus 1.96 standard deviation of the sample mean. Okay, and that is, we form an interval from 1.96 standard deviations below the sample mean to 1.96 standard deviations above the sample mean. So if sample measurements gives a value of x bar, meaning the sample average that falls between the two lines on either side of the mean, then the interval x bar plus minus 1.96 standard deviation of x bar will contain, meaning the population mean. So the area under the, look at this, normal curve between these two boundaries is exactly, meaning this one, this area, so is exactly 95%, meaning 0.95. So the probability that a randomly selected interval will contain population mean is equal to 0.95. And as we said, so this area is out of our range, out of our interval, okay, these two areas. So if we are confident that 95% chance that our calculated number will be in between these range, so it means we have over there 0.025 over here, and here we will also have 0.025 over here, right? Okay. And let's take an example. A large bank that wants to estimate the average amount of money owed by its delinquent debtors, that is the mean. So the overdue amounts for the n equal to 100 accounts are given in the table below. So use the data to find a 95% confidence interval for the population mean and interpret the results. Okay. So actually I have converted this one into an Excel file, and let's see the result. So find the sample mean x bar and the sample standard deviation s with technology, meaning with Excel. So here is my Excel sheet, as you can see. So mean that is equal to, so I have used the average formula, as you can see, mean of this range, so meaning, so B2, here's our B2, 2, look, B2 to K11, okay? So the average is 233.28, and standard deviation is 90.34. So here are the numbers, okay? And now, if we, so look at this, go back. If we use this formula, and let's go. Okay, so here are the numbers we have already calculated, X bar and S. X bar is the sample mean and S is the sample standard deviation. And let's substitute these numbers in the formula. So as we know, so this is our formula. It's given. So this is equal to this one. And so X bar, if we insert this one instead of X bar, let's go. So this is the number, right? This is the number instead of the, we have substituted for X bar, 233.28, we have calculated. And then S should be this one, right? It should be this. Look at this. S is, this number is the S, okay? So if we do the calculation, finally we found these numbers. So that is 233.28 plus minus 17.71. So which is equal to, this is the lower limit and this is the upper limit, okay? So this is the interval. So the estimate is that the mean amount of delinquency for all accounts falls within the interval 215.57 to 250.99 or 251, we can say. So the confidence coefficient is the probability that a randomly selected confidence interval encloses the population parameter. That is the relative frequency with which similarly constructed intervals enclose the population parameter when the estimator is used repeatedly a very large number of times. So the confidence level is the confidence coefficient expressed as a percentage. For example, 90%, 95%, okay? So 95% confidence level, if our confidence level is 95%, then in the long run, 95% of our confidence intervals will contain population mean and 5% will not. So for a confidence coefficient of 95%, the area in the two tails is 0.05. So to choose a different confidence coefficient, we increase or decrease the area, okay, assigned to the tails, so which is alpha. If we place alpha over 2, why alpha over 2? Because actually alpha is our total, meaning total of sum of this one and this one is actually equal to alpha. So this area. So when we are talking about this part, it is alpha over 2 and this part is also alpha over 2. So that is why we place alpha over 2 or alpha divided by 2 in each tail, and the z value, the coefficient, the confidence interval with coefficient 1 minus alpha is this one, X bar plus minus z alpha over 2 multiplied by standard deviation of sample, okay? So this is the entire formula. So where the z alpha over 2 is the z value with an area alpha divided by 2 to its right and in the standard normal distribution. So the parameter standard deviation is the standard deviation of the sample population and n is the sample size, okay? And note that when standard deviation of the population is unknown and n is large, the confidence interval is approximately equal to this one. So meaning we will be using the sample standard deviation and divided by square root of the sample size. So the conditions required for valid large sample confidence interval for the population mean, a random sample is selected from the target population, fine. So the sample size n is large, that is greater than or equal to 30. So due to the central limit theorem, this condition guarantees that the sampling distribution of is approximately normal. Also for large n, S will be a good estimator of the standard deviation. So when we form a 101 minus alpha percentage confidence interval for population mean, we usually express our confidence in the interval with a statement such as we can be 100 multiplied by 1 minus alpha percentage confident that M lies between the lower and upper bounds of the confidence interval. And the confidence interval for a population mean, that is students' t statistic. So instead of using the standard normal statistics, z equal to x bar minus population mean divided by standard deviation of sample mean. Okay, so these are the formulas we'll be using, and t value is equal to this. Okay. So the t statistic has a sampling distribution very much like that of the z statistic. So mound shaped, symmetric with mean 0. So look at this. This is the t distribution, and this is the normal z distribution, almost same. And so the actual amount of variability in the sampling distribution of t depends on the sample size n. A convenient way of expressing this dependence is to say that the t statistic has n minus 1 degrees of freedom. And you just have a look, the three curve. So this is the standard normal, and this one is behind the degrees of freedom is 13, and this one behind the degrees of freedom is 5. And we'll be solving some problems based on the G and T statistics. So at that time, we'll be discussing more about this. Okay, so thank you so much. Let's go to the solutions to the problems.